Hi everyone, I'm Aoife van Linden Tol. Sorry about my strange Irish name, but if you kind of take away the A and the O, it makes a little bit more sense. You say it like Aoife. Anyway, I'm really excited to be in this space. It's so cool, and I had a lot of fun yesterday or day dancing around in here while everything was going on. I couldn't resist. Anyway, I'm going to kind of crack on because I've prepared quite a big talk and I've got a very little amount of space. So I'm going to kind of get going. I'm going to tell you a bit about myself and my work, and talk about the residency project, and also some of my experiences at the European Space Agency and what it was just like, to give you a bit of a feel for what it was like to be there. And then just touch on what I'm doing now at the Futurelab at Ars Electronica, and then kind of finish off by showing you a few of the kind of sketches and ideas that have evolved so far. There's a lot of work still to do to make the project happen at Ars Electronica Festival in September, but I'm just going to give you a little peek into where it's at and how my mind works a little bit. So I work with explosives. I make art with explosives, which I started doing way back at university, and I'm going to explain a little bit more about that. I was always very interested in art and chemistry and cosmology, and all of these things kind of fed in to the decision of why I started working with this phenomena. Here's some of my ingredients. So I don't use paints, I use black powder, which is gunpowder. This is a lump of plastic explosive. It actually looks a bit like Play-Doh in reality, and some nitrocellulose, which is also quite fun. This is me firing. This is what we call a striker. So when I press that button, that's kind of the fun bit. There's quite a lot of preparation when you're setting up an explosion. You kind of spend quite a lot of time setting everything up, and it's a very slow process. And this is the 1 second where it all happens. It's quite exciting. This is one of my very early works. It's sheet aluminium, and it's been ripped through with detonating cord, which is plastic explosive in a rope, basically like C4 in a rope. And they use it in the military quite a lot. And I use this to cut through the metal, and the idea behind this was it was about density and matter. It was meant to give you a really visceral feeling. When you look at an object like this and you see how it's been ripped apart, you can't help but think about how that would rip you apart. And something strange started happening when I showed these works. I was at art school, and at art school it's very conceptual based. Art school, it's very important what you think about your work, why you're doing it, and expressing your ideas. And the audiences would come up to me and start talking to me about their really personal experiences in life, and telling me quite intimate stories about themselves, which I wasn't quite sure how to react to, because I was so focused at that time on what it was I was trying to say through my work, that I was a little bit confused by this reaction by people. That it was so, I would try to explain to them what it meant to me as well, and they just wouldn't even hear it. They just were so focused on their own experience, which actually I came to embrace, but I'll talk about that in a little while. I'll show you some more examples. This is an example of a series called Once Upon a Fraction of Time. And it's called Once Upon a Fraction of Time because it's the story of an explosion which happens in such a tiny amount of time that our brains can't understand it. It's millionths of a second. We don't know what a millionth of a second really is like. We don't experience the world in that way. We experience the world in seconds, or maybe half seconds at the most. And by exploding through a piece of paper, through a whole book, I could calculate how long it took for the explosion to pass through each sheet of paper. And you're talking something like 12 millionths of a second. So these explosions, which are made of plastic explosives, travel using a shockwave which travels at 8,000 meters a second. So it's kind of a window into another frame of time, another time frame, something we can't experience. This was a kind of happy accident. It's a huge sheet of copper. And I was trying to do something a bit similar to the spiral that you saw earlier, but I kind of decided that instead of putting the explosives on one way, I'd do it a different way. And what happened was we went inside the big concrete building to keep ourselves protected, and then I pressed the button, and instead of hearing a bang, I heard a bang, followed by a crash. We had been filming this, and when we looked back at the video footage, we saw that this huge piece of metal, which was, it's copper, it's 2 meters by 1 meter, and it weighs, nearly as heavy as a person. And it was thrown 20 feet up into the air, mangled into this big mess, and then it dropped back, deposited back on the ground again. And I didn't really know what to do with it for a long time. It didn't really work as a sculpture, it didn't really work as anything. And I put it in the photo studio and took photos of it and got these really amazing photos of this copper liquid, golden, fiery, toffee amazingness, which I love. So, happy accident. This, coming back to what I was saying earlier about people coming and talking to me about their emotions, I realized that I needed to embrace this. It wasn't particularly a phenomenon that I was looking for, but I had to, I realized that it was important because it had such a strong reaction with people. And I was invited to take part in an exhibition in Berlin, which was all about the explosive power of words and images. And I came up with this idea. It was in Berlin. I'd never been to Berlin before, and I wanted to make something relevant to Berlin. I like being site-specific. I like making new work for exhibitions. So I decided, I didn't know anything about Berlin, and I decided I would let the Berliners tell me what Berlin was about, instead of me making assumptions or trying to figure out a city that I didn't really know. I spent a couple of days there just talking to the curators. So I invited people to bring me objects, this is one of them, to explode, and they had to tell me why they wanted me to explode them. So they told me all these personal stories, and we got about 30 objects, and amazing stories about revenge, stories about new beginnings, letting go of things that they weren't able to emotionally let go of, and it became this really interesting emotional journey. And we had all these stories were exhibited along with the objects, and I tried to explode them in a way that was relevant to the object. So this is the military ID card, and as you can see, this guy doesn't really look like he wants to be in the military, does he? He's got his long hair and his peace sign, and he's very anti-war. And he asked me to blow this up without destroying the photograph, so I used a detonator to create these little, you can just see it's been damaged a little bit. And then here's a big book which belongs, it's the catalogue of BAM, which is the institute who kindly allowed me to work there. I worked under their umbrella and their facilities, and you can see there's a massive hole in this, and this is using what's called a shaped charge. So normally when you have a lump of plastic explosive, it explodes with the same power in all directions, so very evenly. That's the nature of it. But if you shape it in a particular way, you can create a plasma jet, and that plasma jet will puncture a hole through whatever it is you pointed it at. And I happen to point it at this book. So you've got this really deep puncture straight through the middle. Besides kind of some of the big things that I've shown you already, I can also do very delicate explosions. And the idea for this also came from the idea of emotional relationships with explosions that people have. So I created this project called The One I Love, or sometimes I call it Blowing Kisses. And I invited people to give me photographs of someone they love. And this is a photograph. This is the person who donated the photograph. This is her mother, and I blew little kisses on the bottom. I don't know if you can see these. These are very tiny. They're like a few millimeters high. Very, very tiny. No more power in that than a box of matches. But I really like that scale difference and the delicacy of human emotions and the relationships that you have with your parents. You know, they can be very traumatic, but there's always this unconditional love. So this is a performance. This is the first time I did a theatrical performance where we used fuse in the space. with live performers, which was quite risky because, as you can see, they don't have much clothes on. But it was about knowledge, and I won't get into it too much because it'll take too long to explain this piece, but just to show that I started using it in performance. Does anyone recognise this one? This is kind of for the kids. This is BB8 Star Wars model, and I was invited by Star Wars to create a design for the BB8. We were all sent, myself and other artists and some celebrities were sent a little model, 3D printed model about this big, and we each designed our own version, and it was auctioned off for charity for Great Ormond Street Hospital. That's the kind of finished product, which was, I coated it in copper pieces, about 300 individually cut and drilled in copper pieces, and then I masked off some of the areas and exploded it, and I can show you a little bit of the process of how that happened. That's what it looks like when I'm working on things, small things. This is a piece called Scorched. It consisted of 26 blocks of ice, which I made myself, and I drilled holes through these ice blocks. And live at the event, I threaded these, you can see these kind of coils, this is fuse wire, and I threaded them all together. And then I lit the fuse wire, and something surprising happens when you put fuse through a hole in ice. It actually burns it. You wouldn't expect ice to burn, but it does. And as it does, it creates this black mark, which it ends up being a line through the middle of the ice. So you get a drawing, essentially, this abstract drawing through 26 blocks of ice, uniting them all. And then over the course of the evening, the ice melts, and there's no more drawing. And it's a little bit about the melting ice caps, and it's a little bit about working together to be one thing. I'm not going to go too much into it, it's just to give you a little bit of an idea. And here's a little shot of it, of the fire passing through. There were really beautiful effects on the ice as well as it was melting. So I'm going to tell you a little bit about the Starstorm project, which is the project I'm working on at the European Space Agency to be shown at Ars Electronica. And this was a proposal idea. So I'm just going to go over to my computer and look at my notes because I can't remember off the top of my head. So let me just remember how I'm notes about this. So the idea behind the project is that I will use the research from the European Space Agency about the physics of the stars and our sun in particular, because it's our closest one, so we know a lot more about it, and the solar-terrestrial relationship, so the relationship between the sun and our own planet, the Earth. And the aim is to design a series of what I hope will be powerful and poetic explosive performances, using a range of explosive materials. Each explosion will in some way reflect a specific phenomenon taking place every moment in the stars across our universe. So what kind of physics, what kind of phenomenon, composition of the stars, life cycle, magnetic behavior, light production. I can give you a few examples. This is a UV image of the sun's atmosphere. It's a false colour to distinguish between the different energy levels. And the sun, just to draw in some why I'm fascinated by the sun as well, is that it's essentially a perpetual thermonuclear explosion going on inside of it, just on quite a massive scale. Coronal rain, so you may have seen this in deep space before. It's the coronal rain is the plasma from the sun's surface is made up of plasma, and it gets very hot and it starts to evaporate. And you get these circles, you can see that it's the magnetic field lines, and you can't normally see the magnetic field lines. You can't normally see the magnetic field lines of the Earth either. But as the plasma is charged, it has a positive or negative charge, which means it follows the line of the magnetic field. And as it does so, we can see the reflected light. So this plasma reflects light and we can see it. As it goes to the top, so it's evaporating along these field lines. So imagine these magnetic field lines are like the superhighways for the plasma. So the plasma's going along its superhighway and it starts going further and further away from the sun, and it cools down and it starts to clump together and fall back to the surface. Solar mass ejections, solar flares. So this is huge amounts of matter leaving the sun's surface and hurtling out through space, often towards us. Magnetosphere of our Earth. So it's really shaped by the sun, and a lot goes on here. I think I don't have that much time, so I won't talk about it too much, but I'm very interested in this. It's particles getting trapped in this magnetosphere, getting charged up, and when they eventually make their way to Earth via the poles, they become our northern lights. So, supernova, some of the biggest explosions in the universe, arguably. Arguably, as I found out at European Space Agency, because they do argue about these things. Everyone's convinced that in their particular field, there is the biggest. But anyway, this supernova create a lot of the sun, inside the sun, a lot of the elements that are made, so hydrogen, helium, oxygen, carbon. But in the supernova, you get the creation of gold, you get the creation of uranium, you get the creation of copper, which is my favorite element. I have a favorite element. I'm sorry. So yeah, I'll talk about the European Space Agency and what that was like. So I've just spent 6 weeks there altogether, actually more because I did a few previous trips. The first trip was here. This is the control center in Darmstadt. So this is where, this big room here is where they control the takeoffs and the landings for all the major missions. And we were in this space as, with the Mars XO, there was 2 missions. It's one mission, but they had 2 objectives. One was to land a test spacecraft on the surface to do some testing in preparation for the main mission in 2018, I believe. And then the other was a trace gas orbiter, which is aiming to orbit Mars and study trace gases. So it's actually looking for methane on the surface of Mars to find out whether it's produced via geological means or biological means. So looking for life or ruling it out, in other words. It's quite exciting. This is the moment we got the signal from the trace gas orbiter to show that it survived.
The radio frequency is now switched to the high-gain antenna during the maneuver itself. We were transmitting with the low-gain antenna, so a much weaker signal. The spacer is fluid in an actual.
So there's quite a lot of tension. We've been waiting for hours.
So this might take a few seconds.
Okay. So now.
But this is something happening.
So I just wanted to show you a little bit of the atmosphere, what it was like. That was one of my first visits, and it was just amazing being in that space with all the people. I met loads of people who built various different parts of the spacecraft and talked to them. It was electric in there. It was great. This is the main facility, ESTEC, and my office was. Oh, I haven't got the laser pointer. I wanted to show you where my office was. It's like on the top, on this like these blocks. It's up at the top there. Yeah. That's sort of in there. That in there. And it's nestled amongst the dunes on the coast of Holland. It's really beautiful there. This is my first day. I was walking along the beach, and I felt it was quite magical because I was kind of like quite daunted by this journey as well. I mean, obviously I was amazed by it, and then I was walking along the beach and saw this massive rainbow and thought, oh yeah, it's all going to be fine. I'm where I'm supposed to be. Just to give you a feel, I'm just going to give you a feel of what it's like there. So this is my office. This is so I was going to lectures. This is a lecture about high velocity impacts across the universe, and the lecturer spoke a bit about his facility in England, which does a lot of impact testing as well, which they use to learn about outer space impacts. This is a lesson. tutorial about how to use, by one of the scientists, about how to use a program which gives you access to data from a lot of the satellites of the sun. So it's kind of literally being able to log on, download, and kind of get images like this and study them, which was really great. So, you know, having all that information at your fingertips and just being able to download it. And I mean, you can see a lot of these kind of images online, but being able to really get into the system and slow it down and speed it up and do all of that, really useful. This is some of the kind of whiteboard lessons I was getting. This was about solar turbulence of the solar wind. So this is, again, talking about all the different particles and how they travel along the magnetic field lines, and then how those in themselves get disturbed along the way. This was a really I have to say, this particular meeting with plasma physicists, this was one of the toughest ones I had. A lot of them I could really get to grips with what they were saying, and this I understood, but there was a certain point in this conversation, I was having lots of conversations with different scientists, generally about an hour long, talking about their work and things like that, and just really delving in as deeply as possible and finding out as much information as possible. This one was challenging at some point. This is some of the labs that I visited. Some really cool equipment, which I can't actually remember what it does, but it's really cool. Okay. This is a spacecraft that landed back on Earth, and there were 7 different versions of this, but one of the things I loved about it was just the texture. You could really get up and smell it. You could still smell the burning that it had when on re-entry. This is one of my favourite spaces in the European Space Agency. So this is the life-size model of the Columbus module, which is part of the International Space Station, circling the Earth every 45 minutes. And it's life-size, and you can get in there, and you can pull everything out, and you can test it, and you can pretend you're floating in space. And it was really, I loved being in there. We looked at the sun through a special telescope, reflecting it onto paper with the little contraption thing. That was quite fun, just getting out and doing little practical things. Okay, so this is sort of one of my favourite things, experiences at the European Space Agency. I started doing, as the project developed, and this is sort of coming into the second term, so the first term I spent 3 weeks there, and then the second term I spent another 3 weeks, and the first term was generally lectures, talking to scientists one-on-one, and then the second term became much more dynamic and much more open, and by that time I had an idea of how this project was actually going to shape, and I wanted the scientists to come in and really detail that and really get more involved themselves and share ideas and kind of help shape the project and take some ownership of it as well. And this was actually terrifying for me because I never open up my creative process. I am very, very, very private about my work. I work very hard to develop a project on my own, and I present it to the rest of the world when it's great. So when it's perfect and it's everything makes sense and it's visually and conceptually solid, I present it. And so this was really terrifying for me, and it was the best thing I could have done. What they're doing right there is right at the beginning of the project, of the session. There were a few more people in there as well. It was kind of busy. I said, right, if you were an explosion, any explosion in the universe, what would you be? So they all got up and started drawing. I was like, no, you've got to draw it. You've got to draw it on the board. So just trying to get them physically involved as well as mentally. And what was also really great about this was that a lot of these scientists work in very different fields. They have specific research papers to write. They work in very different fields. Right here we've got a plasma physicist who is also Matt Taylor, who works on, he was very integral into Rosetta, so the landing on the comet, which many of you may have seen. It was a really popular mission. Solar physicists, people who build models, Jacobo builds models, so kind of like really varied people, and they don't always know what each other are doing. So getting them into a space where they have a shared goal and a shared purpose was quite unusual for them. It was really something new and quite exciting, I think, for everybody. I can talk about that slide forever, but I'm going to move on. So then I also, the second term, ran a workshop. So we invited scientists, engineers, faculty staff to come and join the workshop, as well as some guests. And the project was called Make Your Mark. It was based on the concept of, I mean, this is one of the things that really struck me at the European Space Agency, was that how everybody researching or studying made their mark on history somehow, or is making their mark on history, and you don't always know how. You write a paper, and that might not really have much relevance for 5 years, but then somebody will build on it, and there's this essence of individual work building for this shared greater knowledge. And so I got people to choose documents that they felt represented someone or something that made their mark on history, and we worked with these documents for the workshop. And I also ran them through some of the conceptual processes of making my work and the physical processes. So here I got everyone's hands dirty, got them to use charcoal powder to make drawings, which is really a way that I draw a lot, because normal drawing can't really express the energy of an explosion, and so I often throw powders at the paper, because it just gives me a little bit more of an idea and expresses a bit more. I'll show you that later. This is another project, participatory event that I did one afternoon. It sort of bridged the lunchtime, and there's over 3,000 people working at the European Space Agency at that site. And I opened up this project for everybody to just stop by and participate in. This is a print, a limited edition print, which was a collage made from elements of the Outer Space Treaty. And we asked people to make their mark on it, and they used lemon juice bombs. So I wasn't allowed to use explosives, unfortunately, at the European Space Agency. So we used these lemon bombs instead, and we just got people to physically make their mark on it. And while they were doing it, the ulterior motive to this was to engage them in a conversation and get them to think about how they make their mark on the world and what it means to them to have an influence on the environment around you, whether it's through their science or whether it's their families or anything. And really was great to just talk to so many people and open up a dialogue with people in a way that they're not used to. And so the lemon juice, we leave it to dry, and then half an hour later, they come back and blast it with a heat gun, and you start to reveal where the lemon juice has been. It burns quicker than the rest of the paper, basically. So that kind of relates to this idea that I was speaking about earlier about things revealing themselves later. So there's one of the prints finished. Then we did a little excursion to the beach. The friend Yolanda, she does quite a lot of educational outreach with children, and she creates these water rockets workshops for children. I thought, this is great. I really want to learn how to do this, because I do workshops for kids as well. But also, it was great because we got a little team together and took the scientists out of the space and into the beach, and just something so simple. Look, this jogger, he doesn't know what's about to happen. Something so simple but so beautiful, really a great experience for me. Oh, there it goes. Where is it? Wait. This is really fun. You can do this with kids. It's so easy and cheap to do, and it's a great way to sort of get people thinking about space. And okay, I think I haven't got much time. How long have I got? 5? Kind of. Okay, this is the rocket after it landed. This is my studio by the end. Bit of a mess. But I loved it that it was a mess, because it was just such a dynamic space, that second trip. Okay, so what am I doing? I'm nearly at the end. So what am I doing now at Futurelab? So, okay, this is a really boring graph, but I couldn't really find anything else to show. I'm working with explosives. One of the things I really became interested in is the tipping point. So the tipping point is when you go from one state of equilibrium to another, completely another state of equilibrium, but of a completely different value in an instant. So there's all or nothing and nothing in between. And I wanted to try and highlight this as part of the performance. And I don't really use technology much in my work. The explosives have a little bit of technology, but it's really simple, linear, electrical wiring, and that's about it, really. Maybe some time delays. So Futurelab are really helping me to incorporate a kind of technological way to highlight this tipping point. So when the performance starts, I'm hoping that the audience will cause the explosion in the first place, whether that's through measuring their heart rates and getting everybody in the room's heart rate down to a certain level, or we'll use some lasers so that we'll measure the kind of movement in the room, and when the movement is within certain parameters, then it will initiate. So everyone will have a shared goal in order to help this happen. So just to give you an idea of how I develop my ideas, I don't really take data and turn it into work. I'm not making work that educates you about science. It's very emotional, like you may have gathered. It's very abstract. And on my process, I create kind of drawings like this with black powder, with charcoal powders. And they're very abstract, and they don't always mean anything to me fully at the time, but they're inspired by different things. So with this piece, I was quite inspired by spectrums and spectral emission and absorption lines, which I don't know if you know much about. I don't really have time to go into it now, but you can come and ask me later. And then also this idea that whatever way that we look at the universe, there's always a little bit that we can't see. And it's that little bit that we can't see that always intrigues us. This is just wanting to be immersed in the photosphere. So the photosphere is the surface of the sun in which photon we can see, as far as we can see into it. And it's the area where all the photons escape. And I had this idea of this really tumultuous space. And as you can see on the floor here in the sun, you can see these colors like yellow, black, red, orange. And so I'm not going to tell you what's going to happen, because the performance is going to be in September. And so I don't want to tell you what this really means. But there's deep, dark secrets in this image. This is another image. I can tell you a little bit about this. So this is like, we always look at the universe and we want to imagine it from the outside, as if we're looking in on it, as if we can see it as a whole. And when the scientists doing the models of the universe, they always create a box first. So I thought that was really interesting. But it also came about because I was interested in the idea of the inherent protection inbuilt into the Earth, so our magnetosphere, and in the solar system has a solar hemisphere, etc. Anyway, I'm going to rush through exactly going to finish. This is another image. I was inspired by Xray binary stars. Well, yeah, conclusion of art and science. Do you have time for this?
Maybe not.
Okay.
But I'm really sorry that we have to rush a little bit, but there's another talk involving space afterwards, and we have to set up some chairs. But as you already suggested, I think you will be happy to answer questions and just keep on talking.
I love because actually we started late, so unfortunately I think I would have been able to finish. But I do love talking to people and answering questions and stuff. So please come and talk to me. It's great.
The last person belongs to you. The last person belongs to you.
Thank you.